couple of weeks ago, I watched a documentary called A Plastic Ocean, Craig Leeson, and I was horrified of the effects that the manufacturing and consumption of plastics is having, not just on our environment, but on our human food supply. Plastics such as water bottles, shampoo bottles, cream bottles, mouthwash, shower gel, straws, and plastic bags in particular are getting into the scientists are claiming that 85% of landfill ends up in the ocean and our waterways. And I'll put some extracts of documentaries at the end of this video to show you, for you to do further research. The problem is not only are plastics destroying our marine environment and land environment, they are destroying our marine life, and they're destroying marine life and land animals, and they're actually getting into our human food supply, which is now is actually very dangerous. So plastics break down into microplastics, and they get into they're consumed by marine life and animal life, and we in turn we are eating that food, and so therefore we humans are ingesting that food into our system. This is a massive problem. I would say that the production of plastics is the biggest environmental problem in Australia and throughout the world. And I would like to promote to ban the manufacturing of plastics as much as possible, and also recycling of current plastics. So it's plastics and other forms of polymers, but also synthetic fibers that's made in clothes, that comes from clothes, and it gets through our washing machines and our drainage, and it ends up in the water sewage system and the drainage system, and ends up in the ocean bodies. It ends up in the waterways, in the rivers and the ocean bodies. So that's massively problematic. All these plastics, they break down into what's called microplastics, and they end up being ingested by marine animals and land animals, and we in turn as humans, when we eat that food, we are ingesting plastic now. So we really need to promote the banning, not just recycling. We really need to promote not just recycling, but the banning of the manufacturing and production of certain types of plastics as much as possible. Thank you.
These tiny pieces of plastic that are floating on the surface of the ocean come from larger pieces. Over time, the sun's ultraviolet light, ocean wave action and salt break it up into smaller pieces called microplastics. Microplastics have rough, pitted surfaces. Waterborne chemicals from industry and agriculture stick to microplastics, making them toxic poison pills.
So what this means is the feeding that's occurring on the surface of the ocean has these plastic fragments floating around and is actually intermixing in the food chain.
When animals eat plastic, they're also consuming the toxins attached to the plastic. Toxins pass into the bloodstream. There, they bioaccumulate in the fatty tissue and around the vital organs. When animals use the stored fat, the toxins circulate around the body, interfering with reproduction, metabolism, growth, kidney, and liver function.
That's the part we like to eat, and that's where these chemicals migrate to.
You expect that you're finding derivatives from plastics in the blubber of these animals because they're consuming other animals that are directly consuming the plastics.
Exactly.
And so if the plastics are in the food chain for the dolphin, they're also in our food chain.
Exactly.
I remember the first time I saw a blue whale.
Oh, look. Wow.
I've followed them since childhood.
What do you think it's from? Is it from a ship?
I could see plastic everywhere. We were in what we thought was a relatively pristine environment. I started to wonder what was happening in oceans elsewhere on the planet. Growing up, my world was the ocean. It's where I feel the most spiritual.
As a freediver, it was the place where I proved myself to myself. Finally, have the opportunity to pay the sea back.
Only a fraction of the plastic that we produce is recycled.
This is never going to degrade. It's got nowhere to go.
This was something that these animals, they were forced to endure because it was man-made and we'd put it into their environment.
The record is 276 pieces of plastic inside of one 90-day-old chick.
If the plastics are in the food chain for the dolphin, they're also in our food chain.
Exactly.
Communities are built on these landfill sites.
So sweet potatoes, corn, sugarcane, all growing on 40 years of garbage.
Do you have anything not wrapped in plastic?
No.
No.
We have to make our life better for our kids' children. Change is possible. It starts with us.
There's been a lot of attention lately on the tiny additives in our shower products. It seems, without many of us realising, they've been stuffed full of plastics.
They're designed to make things a little bit rougher and to get a better clean, but a lot of the products that they're used in go straight down the sink and then out into our lakes and rivers and oceans.
Called microbeads, these tiny plastics have been causing so much alarm that supermarkets are in the process of banning the bead from their shelves. But in the stomachs of our seafood, researchers are mostly finding a different kind of microplastic.
Major thing that we were finding were these fibres, and so that really begged the question, where do they come from?
They're going down our household drains at an astonishing rate, but barely anyone seems to realise.
If animals that we're eating are eating plastic, we could potentially make that assumption that these chemicals are in our seafood.
What kind of microplastics are ending up in our marine life, and how much damage can they actually do? When I decided to take a closer look at microbeads, I didn't realise just how close I was going to have to look.
They're so small, aren't they, these tiny little beads?
Oh, they're tiny. We're getting sizes right the way from 1 millimetre all the way down to several micrometres, if not smaller.
The man helping me filter these rinse-off cosmetics is ecologist Dr. Mark Brown. He's been consumed with the problem of microplastics in the oceans for more than a decade.
It is a huge problem. So if you look at the amount of plastic in the environment, over 85% of that is microplastic.
The problem with microbeads is they're so small you need a filter paper to catch them. They're too small for our water treatment systems, but small enough to be easily ingested.
Over recent years, the amount of research has increased, and we've started to show that they're persistent, bioaccumulative and toxic.
3 years ago in the US, scientists trawling for microplastics in the Great Lakes found concentrations as high as 400,000 particles per square kilometre. They were amazed by how many tiny spherical beads they found in the mix.
It isn't just microbeads, it's much larger bits of plastic breaking down into the same micrometre-sized fragments. And so we're really concerned as to whether or not these particles could be accumulating in humans and wildlife.
The evidence shows they are, even at the very base of the food chain. Zooplankton, for example, are a major source of food for fish, whales and seabirds. These were filmed under a microscope in just one drop of water. Normally, they draw algae towards their mouth by creating currents with their legs. But when tiny fluorescent particles of polystyrene are added to the water, they eat those instead. Microplastic is now regularly being found in wild-caught zooplankton in the North Pacific. Just through eating these tiny crustaceans, salmon are thought to be consuming around 90 particles of plastic a day.
So these particles look so small that if you swallowed them, it doesn't look like they'd do much harm. I mean, don't they just sort of pass right out the other side?
Well, this is what we thought until we started doing experiments whereby we were actually feeding these types of particles to them. We were astounded by actually what we found.
I'm much more disturbed by what Mark shows me next.
So we know that invertebrates, in particular mussels, are exposed to microplastics in the environment. What we really wanted to find out is whether or not these tiny particles of plastic get any further than the stomach itself. So we exposed these mussels to tiny particles of polystyrene, and we then tracked these particles in the tissues of the mussel itself.
This footage, captured by marine scientists at the University of Connecticut, shows how tiny bits of plastic are drawn into the mussel and along the gill filaments. They get trapped here just like food particles and pass down the ventral groove into the mussel's mouth. But no one knew they could penetrate the gut barrier until Mark took samples of the mussel's blood. When the blood is analysed days later under a special infrared microscope, the molecular vibrations of plastic can clearly be identified.
Here you see right in the middle of the actual slide there is the polystyrene bead.
So that means that the plastic has made it from the stomach of the mussel into the circulation?
It has, yes.
That's astonishing. So how long have you seen the particle remain in the circulation?
They've lasted in the actual mussel 4 months. But more disturbingly, as these particles of plastic get smaller, which is what they'll likely do through the breakdown in the environment, the rates of transfer actually increase massively. The concerns that we have really is that it can cause inflammatory responses, so the body of the mussel itself recognises it as a foreign particle and starts attacking that. Because the particle can't go anywhere, you get scar tissue forming around that.
But the reaction to a foreign body in the tissues is just one of the side effects.
What's most concerning researchers is not just the physical damage caused by microplastics when they're ingested, it's the toxic load from the chemicals they carry.